Section 2B, transformations of functions. Now we're looking at this question right here, and we're going to describe how it compares to the original or parent function. Now the original parent function is absolute value of x, and we know that that looks like that. So what does this one look like? Well, again, recommended to plug your numbers into a table. So -3, -2, -1, 0, 1, 2, and 3. If you do that, the absolute value of a -3 is 3, but then there is this negative. So that negative makes it negative again. If you plug in a -2, which is this one, you plug in -2, absolute value of -2 is +2, but again the negative is sitting on the outside, so it makes it negative again. So -1 will stay negative. Plug in a 0, you get 0. Plug in a 1, absolute value of 1 is 1, but again we make it negative. And then -2 and -3. So our graph will change a little bit. At 1, well, I'll just do this. So -3 gave us -3. -2 gave us -2, -1's -1, 0, 0, and so on. And we get something that looks like the original one, but it looks upside down. How's it described then? Well, we would use terms like a reflection, because it looks like the same thing, but it's just reflected. So we would say a reflection over the mirror. In this case, the mirror is the x-axis. So a reflection over the x-axis is good enough. Now, another kind of question, which has a root in it, so number 17, this is the parent function, and the parent function for that looks like this. If you plug in a negative number, you don't get anything out. Nothing works if you plug a negative x in. But if you plug in a 0, you get a 0. If you plug in a 1, you get a 1. If you plug in a 2, well, root of 2 is a little bit over 1, but still small, and so on. And what you're going to get is a graph like this. So what kind of graph then is, compared to that now, oops, sorry about that. What kind of graph will you get from this? All right, well, again, if you're not sure, the best way is to plug in an x and y, or an x, and see what you get. So x and y. Now, typically we start at -3, but there's going to be something interesting here, and we'll show what happens. These numbers have moved the graph. Where? We'll find out. If you plug in a -3, -3 minus 2, we're plugging it in, you get -5 minus 1. Root of -5 can't do, so you can't do it. So -3 gives you nothing. -2 will give you nothing. -1 minus 2 is -3, that gives you nothing. Plug in a 0, 0 minus 2, root of -2, nothing. Plug in a 1, nothing. Now if you plug in a 2, 2 minus 2, rooted, is 0, root of 0, which is 0. So you get -1. Now we have something. If you plug in a 3, you're going to get 3 minus 2, which is 1. Root of 1 is 1. 1 minus 1 is 0. And what's going to happen is you're going to get a graph that doesn't even start to show up until +2, which gives you a -1. And then 3, which gives you a 0. It's going to look like this. Now if you compare the two, what happened? Well, the red one is the original. So when you compare it to this one, what happened? Well, I like to focus on the origin, or the beginning of the graph typically, or the origin if it goes through it. So if I look at this one right here, sorry, if I look at this one right here, it's supposed to start at 0, 0. But in the one we're looking at, it doesn't start at 0, 0. It starts right here, which seems to be, instead of here, it went 2 units to the right and down 1, and then it recreated itself. So you would say that this has been shifted. So we would say shifted 2 units. It's always about where it originally was to where it goes. Shifted 2 units right, and it shifted 1 unit down.